Question number 7 is about chemical reactions and electrolysis. The question says, this question is about chemical reactions and electricity. Electrolysis and chemical cells both involve chemical reactions and electricity. Explain the difference between the processes in electrolysis and in a chemical cell. Now, what happens in electrolysis? We supply direct current for reaction to take place. Whereas in a chemical cell, chemical reaction produces direct current. Next part says, a teacher demonstrates the electrolysis of molten lead bromide. So the moment I see molten lead bromide, I need to remind myself that there are only two ions. Say 2 ions. Now this time it is lead and bromide. This time it is lead bromide. So the two ions will be lead, which is 2 plus, and Br1 minus. This ion will change into Pb solid, whereas bromine will change into Br2. You can say liquid. Here it says bromine is produced at the positive electrode, and that's true because bromide ion has a negative charge, so it will be attracted towards the positive electrode. Complete the half equation for the production of bromine. You should balance the half equation. So we've got Br minus, it will change into Br2, and each bromine will release 1 electron, so in total there will be 2 electrons released. Now to balance this equation, I'll have to put 2 before Br minus. Next part says, 2 aqueous salt solutions are electrolyzed using inert electrodes. Now this time it says aqueous. So aqueous means 4 ions. Complete table 4 to show the product at each electrode. So let's first consider copper nitrate. So it is a solution. So this means there will be copper ion, which is Cu2 positive. There will be a nitrate ion, which is NO3 1 minus. And then there will be 2 additional ions due to water, which is H plus and OH minus. Now this is my polyatomic ion. So OH will have priority, and this will then change into O2 gas. In this case, copper is below hydrogen on reactivity series. So Cu2 plus ion will change into Cu solid. They've already told us that on negative electrode, copper is produced. On positive electrode, OH minus will be attracted, it will change into O2. So I can say it will be oxygen. I'll do the same thing for potassium iodide. Here, potassium iodide is K, which is 1 plus. Iodide is 1 minus. Now there will be 2 additional ions because it is again solution, so it will be H plus and OH minus. Now whenever you have halogen ion and OH minus ion, then it is always the halogen ion which will change into X2. In this case it will change into I2 because it is iodine. On reactivity series, hydrogen is below potassium, so this will change into H2 gas. Now H plus is positively charged, so this is the product on the negative electrode, so I can say here it will be hydrogen, whereas on the positive electrode it will be iodine. The next part now involves a bit of reading. It says, some students investigated the electrolysis of copper nitrate solution. Remember, 4 ions using inert electrodes. Inert electrodes are unreactive. Says figure 4 shows the apparatus. So we've got positive electrode, we've got negative electrode, we've got DC power supply, an emitter, and we've got copper nitrate solution. It says the students investigated how the mass of copper produced at the negative electrode varied with time and current. So they carried out 2 investigations. One is mass, versus time, number one. And the second one is mass against current. This is the method used. Weigh the negative electrode. So this will give you M start. Set up the apparatus shown in figure 4, which is over here. Then it says adjust the power supply until the ammeter shows a current of 0.3 amps. Switch off the power supply after 5 minutes. Rinse the negative electrode with water and allow it to dry. This will give you the mass final. And if you use these two masses, then you can work out change in mass for the electrode. Then it says reweigh the negative electrode. They're doing this so that change in mass for the electrode can be worked out. Then it says repeat step 1 to 6 for different times and repeat step 1 to 7 at different currents. The question says some of the copper produced did not stick to the negative electrode but fell to the bottom of the beaker. Suggest how students could find the total mass of copper produced. So the total mass of copper produced will be mass of copper from solution plus change in mass of negative electrode. So to find this, number one, we'll carry out filtration. Now the filtration will give you two products. One will be the residue and the other one will be the filtrate. It's the residue that is solid copper. So we'll then say wash residue and let it dry. From here you will get mass of copper from solution. To find the mass of negative electrode, you will do M final, take away M start, and this will get us full 4 marks on this question. Fairly easy question. So the question continues and it says the students plotted their results on a graph. So the total mass of copper produced in grams is on y-axis, and on x-axis you've been given the time. So you can see here, for same amount of time, if you use different amount of currents, because these 3 lines are representing different currents, you will end up getting different amount of total mass of copper produced. It says the student correctly concluded that the total mass of copper produced is directly proportional both to the time and to the current. It is directly proportional. Directly proportional means it must meet 2 conditions for a graphical data. Number one, it should be straight line, and number 2 is must pass through origin. And in this case, all 3 lines, they pass through the origin and they are all straight lines. It says, how do the results in figure 5 support the conclusion that the total mass of copper produced is directly proportional to the time? So all we have to say is we just have to repeat this. We'll say straight lines passing through origin. Next part says, how do the results in figure 5 support the conclusion that the total mass of copper produced is directly proportional to the current? Use data from figure 5 in your answer. For this question, we are not provided the graph of total mass against current. So we can't use the lines only to say why it is directly proportional. But what we can do is we can extract the data. For example, to answer this question, I will use the space here. So to show that current and mass are directly proportional, so I will say when the current is 0.3 amps, the total mass produced was 0.06 when the current is 0.6 amps, now the total mass produced is 0.12. When it is 0.9 amps, the total mass produced is about 0.18. So you can see from here to here, the jump is 0.06. From here to here, it is 0.06. Same thing on the left side, it is 0.3, and here it is 0.3. So I can use this data and I can say when current increases by 0.3 amps, mass increases by 0.06 grams, and that would be the acceptable answer. The next part here says copper nitrate solution is blue. Suggest why the blue color of the copper nitrate solution fades during electrolysis. So if you recall, we said you've got ions which are Cu2 plus and NO3 1 minus. Then we've got H plus and OH minus. And we said this OH minus will change into O2, Cu2 plus will change into Cu solid. So as the time will pass by, what will happen to the amount of copper ions? They will decrease. So we can say copper ions are being removed. Last part of this question says, determine the number of atoms of copper produced when copper nitrate solution is electrolyzed for 20 minutes at a current of 0.6 amps. It says number of atoms. So based on this data, I can use the graph given to me here. I can say when the current is 0.6, I'm going to use this line, and the time is 20 minutes. So against time, which is 20 minutes, the total amount of copper produced is 0.24 grams. So I can say here, mass produced is equal to 0.24 grams. It says give your answer to 3 significant figures. This is again something important. It says use figure 5, which I already did. It says relative atomic mass of copper is 63.5, and they've given us the Avogadro constant, which is 6.02 times 10 to the power of 23 per mole. What does this mean? This means in 1 mole there are this many atoms of copper. We know the mass, we know the AR for copper, so I can convert this into moles. So I can say moles of Cu produced will be equal to given mass divided by AR, which is 0.24 divided by 63.5. If you put these numbers in calculator and solve, we'll end up with a value of 3.78 times 10 to the power of minus 3 moles. Now 1 mole has got this many atoms. We need to find how many atoms are there in this many moles. So we'll write down number of atoms will be equal to 3.78 times 10 to the power of minus 3 times 6.02 times 10 to the power of 23. And if you solve it on your calculator, you'll end up with 2.28 times 10 to the power of 21. Now there is another method of answering this question. So I can say this is method 1. Let's have a look at method 2. It's about ratios and proportions. So in this case, based on this data, I know that 1 mole of copper has this much mass. So I can say 63.5 grams of copper will have 6.02 times 10 to the power of 23 atoms. In our case, we don't have this many grams. We only have 0.24 grams. So I can say 0.24 grams will have x atoms. Now to find the value of x, you can cross multiply and equate, and you will end up with the same answer. So it will be 63.5 times x, which is equal to 0.24 times 6.02 times 10 to the power of 23. To find the value of x, I'll divide both sides by 63.5 and 63.5. This will cancel out, leaves me with x equals 2.28 times 10 to the power of 21. So there are two ways of answering this question, and I have discussed both of them.